Hey guys, this video is mostly going to be kind of mathematical about problem solving. One thing I failed to mention about a series circuit, here's a schematic of a series circuit. One thing I failed to mention before about a series circuit was Christmas lights is a great um, example of a series circuit because if one bulb goes out, all the bulbs go out because there's only uh, one path on the circuit. Okay, so getting that in now. Anyway, we're going to look at how we can calculate voltage in a series circuit of a bulb and voltage of a battery. Okay. So remember, series circuit, there's only one path. So if you are an electron here, there's only one way to go around the circuit to get back to the battery. You have to go through all the bulbs, all right? And what does your path include? It includes picking up, gaining voltage at the battery. Remember, voltage is how much energy each electron carries. And so you pick that up at the battery, where the energy is stored, that is. And as you go around your path, you visit these bulbs, and you drop off energy in each bulb because each bulb needs to light. All right, so you drop a little bit at the bulb we call R1 because bulbs are resistors, we call it R1. Then the second bulb we call R2. And then you drop a little more at R3 so each one can light before you go back to the battery. And the electron's going to go back to the battery empty-handed with no more energy or voltage left. All right, so because they go back empty-handed, they dropped off all their voltage that they gained at the battery. So here's our important point for math here, though, is that the voltage drops add, these three is where the voltage is dropped off. Those add to equal the voltage picked up, I should say, at the battery. So whatever you gain at the battery, these three drops add up to equal what you gained at the battery in voltage. And here's your equation for it. The voltage of the battery equals what is dropped off at R1, that's here. What is dropped off at R2, that's here. And what is dropped off at R3, that's here. So if you add those three drops together, you get what you gained at the battery. All right, so write down that formula. And we're going to use it to solve two practice problems. Our first practice problem is solving for the voltage dropped at a bulb. So draw this out. You could pause and then restart, and we're going to solve the problem. Okay, so we want to solve for how much voltage was dropped at the third bulb. All right, it says we gained 9 at the battery, 9 volts, dropped to 2 at the first bulb, 3 at the second bulb. You might be saying, hold on, don't they split up equally? No, not all the time. There might be one bulb that's brighter than the other, depending on what kind of bulbs you have. All right, so as long as these three add up to equal the voltage at the battery, that's what's important. So let's write down our formula. The voltage of the battery equals the voltage at R1 plus the voltage at R2 plus the voltage at R3. And if there was a fourth bulb, you would write plus the voltage at R4. But we don't have a fourth bulb. So the voltage of the battery, we could plug in for that. That's 9. The voltage at R1, that's 2 volts. The voltage at R2, that's 3 volts. And we're going to solve for the voltage at R3. We're going to solve for this one. So 2 plus 3 is 5 volts. So 9 volts equals 5 plus our answer. So we're going to subtract 5 from each side, and that gets the voltage at R3 all by itself. 9 minus 5 is 4 volts. That would be your answer, because 2 plus 3 is 5, plus 4 more gets you 9, okay? So that's how we solve for the voltage of a bulb. Now we're going to solve for the voltage of the battery in this. So example 2 is about solving for voltage of the battery instead of a bulb. Why don't you pause, write down this diagram, an example, and then restart, and we'll solve it. Okay, great. So voltage of the battery, let's write down our formula, equals voltage at R1 plus voltage at R2 plus voltage at R3. Now this formula, remember, only works for series circuits, okay? Might want to go back to where you first wrote it down and write down that's only for series only. This doesn't work for a parallel circuit. You've studied parallel circuits a little bit. That's for series only. Why don't you go back and kind of say adding up the voltages dropped to get the batteries voltage. That's for series only. Make a note of that. Anyway, so we're going to copy that formula here, and we're going to solve for the voltage of the battery. So it's equal to the voltage at R1, which is 8 volts, plus the voltage R2, that's 1 volt, plus the voltage R3, that's 7 volts. So 8 plus 1 plus 7, well 1 plus 7 is 8, so 8 plus 8 is 16. So 16 volts is the voltage of the battery. Alright, so to get the voltage of the battery, if it's a series circuit, remember, not in a parallel, this is only for series, add those 3 up, alright? Alright guys, so there's your series circuit practice problems. Remember, this isn't for parallel, this is only for series, okay? Good stuff.